Here we are. This section is the last of the different formulas that we're going to need in this unit. Product to sum and sum product formulas. And again, these are ones that are not used nearly as often as the power reduction formulas or the sum and difference of sines and cosine formulas. But again, they are trig formulas and we should get used to seeing them. They are on that formula sheet, so a lot of these we're not going to memorize, right? Right, I told you that the sum and difference formulas for tangent and double angle for tangent and power reducing for tangent are all there. The half angles for sine, cosine, and tangent. These are the 8 formulas we're working on in this section. And just kind of a quick walkthrough. We're not going to spend a lot of time on it, but it is good to see. If you want to take the sine of one angle times the sine of another angle, you can rewrite them in terms of cosines. Okay, same thing with cosines all the way down. And you can turn sums, right, sum of 2 angles, into a product of 2 angles. So how do they work? Here's how they work. Okay, those are the 4 formulas for sines and cosines. I'm not going to memorize them. I'm just going to work with them as they're there. So sine alpha sine beta is 1/2 the cosine of the difference between the angles minus the cosine of the sum of the angles, with the alpha coming first and the beta coming second. Okay, when you subtract them, you want them to be in that order. Same thing for the cosines. And notice the one down the bottom. So it's sine sine, it's cosine cosine, it's sine cosine, and it's cosine sine. All right. What are we going to do with them? So the first one says expresses a sum or difference, the sine of 8x times the sine of 4x. So what formula does that go with? That's a sine sine. Sine sine is the first one. So sine sine becomes half the cosine of the difference minus the cosine of the sum. So the formula says we should take 1/2 the cosine of the difference in the order it gives us, so 8x minus 4x, minus the cosine of the sum, 8x plus 4x. And then we simplify as much as we can, and we don't simplify any more than we can. So 8x minus 4x is 4x. So I get the cosine of 4x. 8x plus 4x is 12x. So minus the cosine of 12x. And that's it. As tempting as it is, I can't simplify it any more than that. So there's my answer. Okay, look at number 2. Number 2 says the sine of x times the cosine of 2x. So what formula is this? Well, it's a sine cosine. So sine cosine is this third one down here. It says take half the sine of the sum plus the sine of the difference. All right, I think we can do that. 1/2 the sine of the sum, so x plus 2x, plus the sine of the difference, x minus 2x. Right? Half the sine of the sum plus the sine of the difference. Well, x plus 2x is 3x, so we get the sine of 3x. Now, over here, we get the sine of negative x. So we've got to go back and think about odd and even functions. The sine of x is an odd function. So that means that the sine of negative x is the same thing as negative sine x. So rather than write this as the sine of negative x, we can write it as minus the sine of x. Right? That's all we can do. That's where we leave it. All right, for number 3, it's a cosine sine. So we've got to go back and look for our formula that has a cosine sine. So which of our formulas has a cosine sine? Here it is, the last one. So the cosine sine says half the sine of the sum minus the sine of the difference. So half the sine of the sum, 5x over 2 plus x over 2, half the sine of the sum minus the sine of the difference. So minus 5x over 2 minus x over 2. So we get 1/2 sine, well, 5x over 2 plus x over 2 is 6x over 2. 6x over 2 is just 3x. 5x over 2 minus x over 2 is 4x over 2. And 4x over 2 is just 2x. So the sine of 3x minus the sine of 2x. Again, it's tempting. You want to go further. You want to try to combine them, but you can't. One of them is the sine of 3x. One of them is the sine of 2x. And unless you really want to get mired in trig formulas on top of this, at this point, let's just leave it like that as an answer. All right. These guys over here are what we call sum to product. Why? Because they start as sums and they end as products. So we've got sine plus sine. We got sine minus sine. We got cosine plus cosine. And we got cosine minus cosine. On the other side of the equations are all alpha plus betas over 2 and alpha minus betas over 2. So they're sums, right? And they're differences. Which one we use depends on what question was asked of us. So look at this first one. The cosine of 75 degrees minus the cosine of 15 degrees. This is a difference, right? Cosine minus cosine. So we look down, the last formula here is cosine minus cosine. It says we should take negative 2 sine of the sum over 2, sine of the difference over 2. So our alpha is the first value, right? That's the 75. The beta is the second value, that's the 15. So the formula says take negative 2 sine, and then what? Alpha plus beta over 2. So 75 plus 15 over 2 times the sine of alpha minus beta over 2. So the sine of 75 minus 15 over 2. Well, 75 plus 15 is 90. 90 over 2 is 45. 75 minus 15 is 60. 60 over 2 is 30. And now we've got ourselves nice unit circle trig numbers. So sine of 45, square root of 2 over 2. Sine of 30, 1/2. So this gives me negative square root of 2 over 2. And there's my answer. All right, look at the second one. The second one says to evaluate the sine of pi over 2 minus the sine of 5 pi over 2. So let's see what formula we should use for this one. We've got a sine minus a sine. So the second formula here is sine minus a sine. It's 2 times the sine of the difference over 2 times the sine of the cosine times the cosine of the sum over 2. So the formula says take 2 times the sine of pi over 12 minus 5 pi over 12 over 2, right? So 2 times the sine of alpha minus beta over 2 times the cosine of alpha plus beta over 2. All right, so the fractions are obnoxious, but other than that, it's not bad, right? On the top, pi over 12 minus 5 pi over 12 is minus 4 pi over 12. But 4 pi over 12 is pi over 3. Now divide that by 2, and you end up with a pi over 6. So I get 2 sine negative pi over 6, which, I mean, I could have just made this a negative 4 pi over 24, right? That would have taken the 12 times 2 and given me 24, and I would have gotten the same thing. Over on the other side, pi over 12 plus 5 pi over 12 is 6 pi over 12. 6 pi over 12 is pi over 2. That's the numerator. Now divide it by that 2, and I get pi over 4. So my second one is the cosine of pi over 4. All right, the sine of negative pi over 6. Well, what is that? That's down in the fourth quadrant, which, I mean, we could also turn it into a negative 2 sine of pi over 6, but let's leave it as it is. The sine of negative pi over 6, so it's a negative. We're down in that second quadrant, so it's a half. So we get 2 times negative 1/2 cosine of pi over 4 root 2 over 2. So this gives me a negative square root of 2 on the top, 2 on the bottom. There's my answer. All right, last thing we're going to do in this section is we're going to work on verifying some identities. So look at this first one. The sine of x plus the sine of 3x over the cosine of x plus the cosine of 3x. Let's work on each one separately and then bring them together at the end. So I'm just going to insert a slide here and rock on here. So the numerator was the sine of x plus the sine of 3x. So sine of x plus the sine of 3x. What's the formula? It's a sum to product formula because I'm starting with a sine of x and a sine of 3x, so it's a form of sine plus sine. Sine plus sine is the one up on top. Right? So sine plus sine is that guy over there. So it's 2 sine of alpha plus beta over 2 cosine of alpha minus beta over 2. So you've got a formula sheet. You can do 2 times the sine of x plus 3x over 2 cosine of x minus 3x over 2. So I get 2 times the sine of 4x over 2 cosine of negative 2x over 2. So this gives me 2 sine 2x cosine of negative 2x. Nope, negative x. All right, now let's work on the denominator. The denominator was cosine x plus cosine 3x. Cosine x plus cosine 3x. And so that's a cosine plus cosine. So if I got a cosine plus cosine, that's the third one down here. So 2 cosine of the sum times the cosine of the difference. So 2 cosine of x plus 3x over 2 cosine of x minus 3x over 2. So I get 2 cosine 4x over 2 cosine of negative 2x over 2, which simplifies as 2 cosine of 2x cosine of negative x. So the original problem asked us to divide those two, to take the sine and divide it by the cosine. So let's do that and see what happens. So let's take the numerator, 2 sine 2x cosine negative x, and divide it by what's on the right side, which is 2 cosine of 2x cosine of negative x. So the 2's go away. The cosine of negative x's go away. And I'm left with the sine of 2x over the cosine of 2x. Well, sine over cosine is tangent, so sine of 2x over cosine of 2x must be the tan of 2x. Is that what we're looking for? Oh, look at that. That's what we're looking for, right? Look at the right-hand side. That's exactly what we're looking for. All right, look at the last problem down here. Sine of x plus sine of y over sine of x minus sine of y. So I could either work with the left-hand side or the right-hand side. I think I know more formulas for the left-hand side, so let's work on that. Let's tackle the numerator first. Sine of x plus sine of y. That's going to be sine of x plus sine of y, this first formula here. So 2 sine cosine, sum and difference. So the numerator, 2 sine of the sum over 2 cosine of the difference over 2. Well, no, there's a whole lot I can do with that quite yet. Let's look at the denominator. The denominator is the sine of x minus the sine of y. So sine of x minus the sine of y is the one that's with a little red arrow there. So sine of the difference, cosine of the sum. So 2 sine of the difference, so x minus y over 2, cosine of the sum, x plus y over 2. And now I'm supposed to divide this whole thing. When I do that, the 2's go away, and I'm left with a bunch of sines and cosines. Well, they don't cancel out, right? I got the sine of an x plus y and the sine of an x minus y, and reverse, right? Cosine of the minus over cosine of the plus. But look what it is that's on the other side. On the other side are tangents and cotangents. So rather than match them up by sines and cosines, let's match them up by what's on the inside. And here's what I mean. Let's take this term here because it has an x plus y, and this term here because it has an x plus y, and let's match them up. So let's make it the sine of x plus y over 2 and the cosine of x plus y over 2. Because remember, all this is being multiplied, right? On the top, sine cosine, on the bottom, sine cosine. So I can move things around if I want without penalty. What am I left with? I'm left with a cosine of x minus y over 2 and a cosine of x plus y over 2. Well, now look at what I have. I've got sine over cosine of the same thing. Sine over cosine is tangent. So this piece over here is the tangent of x plus y over 2. What's over here is a typo because the thing on the top, the thing on the bottom should be a sine. I copied the same thing twice. This should be a sine of x minus y over 2. Right? Because I have the cosine. That's the cosine of x minus y over 2. It was this thing that was supposed to go down the bottom. So the sine of x minus y over 2. Oh, look. Now I have the same thing. Now they're both x minus y over 2's. And cosine over sine is cotan. And now this matches up with the other side of the equation. So the formulas are kind of goofy. You don't use them a lot. But it is important. You're in a trig class. We should learn the different formulas for trig. But if you need these formulas either to verify an identity or to find the value of an angle measure, you'll be given the formulas. You can use the formulas in that formula sheet. Be familiar with that formula sheet as you work through the homework assignments, the labs, and prepare for the tests.